Okay, so let's look at this first problem here. And I know that this doesn't come out well when you print it from the computer, but it's the best we can do. Okay, so what we want to do is we want to make sure that we understand what we're trying to find, because you guys have the math down. The math is not going to be the problem. We just have to make sure that we're understanding what we're doing. Okay, so we're finding some value that satisfies the mean value theorem for this function. So here's the graph of the function, and we're going to look at the interval from 4 to 6. Okay, so what we're trying to do is we're saying, okay, somewhere the instantaneous rate of change is going to be equal to the average rate of change. Okay, so here's the average rate of change, right? That's the secant line right there. So that's the average rate of change on 4, 6. It's just the slope of the line. Okay, so keep that in mind, that we're trying to find some point along here between 4 and 6 that would have the exact same slope. And so, you know, we could kind of just look with our ruler. I kind of move that over. Should be somewhere in here. There should be some value that has the same slope as that. Okay, now we have to make sure, or we have to satisfy some conditions. So the first thing you have to do is you have to determine if the hypothesis, or yeah, I should say the hypothesis of the mean value theorem, or maybe we could say the conditions, are satisfied. Okay, so remember that we said that it has to be continuous on the closed interval and differentiable on the open interval. Okay, and the interval is from 4 to 6. And, well, we have a polynomial here, so we can see it from the graph. Normally you wouldn't have the graph, so I just printed out the graph just so that you guys could see what we're actually doing. So normally you just have the function, but we're going to say, all right, f of x is a polynomial, and so we know that it's smooth and continuous, so we're going to say therefore it's continuous on 4, 6, and differentiable okay. Remember that when we're talking about something being differentiable, we're just saying, you know, there's no discontinuities, there's no sharp corners, there's not an asymptote, there's nothing like that going on. Okay, and we can't be differentiable on a closed interval because we can't take the derivative of an endpoint. That's why it has to be an open interval. Okay, so the second thing we're going to do is we're going to find what the slope of the secant line is. Well, if you want to find the slope of the secant line, and these are your endpoints, you have to find the y values that go with them. Okay, so we are going to find f of a and f of b. And I'm using f of a and f of b because in our original thing right here, okay, it said that we take, you know, our formula for slope, and they called the endpoints of the interval AB. Okay, so that's why I'm using those two things. Okay, so f of a, let's just find f of 4. And all I would do is plug in 4 to that original equation. And I did that already, and that's 6. Okay, so that's telling me that the point 4, 6 is on the graph. And if I look right here, 4, 6. I know it's very hard to read this, but that is the 0.46. So I can kind of put that over here just as a reminder. Okay, f of 6 and that's going to give us -2. And I can see right here f of 6 is -2. So it's really like we're doing a Math 1 problem, although actually this is more like pre-calculus when we called it average rate of change. So we're just finding the slope between those two numbers. Okay, so I'm going to go 6 minus a -2 all over 6 minus 4. That's going to be 8 over 2, which is 4. And 6 minus -2, wait, it should be -4. What did I do wrong? I got 4, 6. Oh, duh, I went backwards. Okay, I should have gone 4 minus 6. Man, that's a pretty basic mistake there, you guys. It's pretty bad. Okay, but I knew it should be negative because the slope is in the negative direction. Okay, so there's the slope of the secant line. Okay, so let's think what our thing said. It said, well, the derivative at some point should equal the slope of the secant line. Okay, so let's find that. Okay, so we found the average rate of change. Oh, I should have put up here that step number 3, find the average rate of change. Oops, gosh. Okay, it's nighttime, you guys. I don't work well at night. Okay, that's what we just did right there. Okay, the fourth thing we're going to do is we're going to find f prime of x. So we can just look at our original function right up here, and f prime of x is -4x plus 16. Okay, so there is some number in here that makes this equal to -4. Okay, so I got to figure that out. So that's what step 5 is. We're going to find the value and that value of c, which is just an x value, that makes f prime of x equal to the average rate of change. Okay, and this, well, you have to always think about what you're doing. Okay, so we want that to equal -4. So -4x plus 16 will equal -4 when x is equal to 5. So the derivative when x is 5, or in this case we'll say c, we're going to call this value that we found c. And we will say the value c equals 5 satisfies the mean value theorem and I could have just said MVT on that interval. So it's telling me that when x is 5, and there's all these shadows in this room too. Terrible lighting in here because I never use this room. So when it's x is 5, okay, let me see if I can see it. It looks like it's about right there. That the tangent at that spot is going to have a slope of -4. So I can just, I know its slope is -4, so I could go 1, 2, 3, 4 over 1 to just to help me draw it. And remember, I know I didn't go down a full 4 and over 1 because slope is just a ratio. Okay, so what I found is that point at the point 5, when x is 5, the instantaneous rate of change, or the slope of the tangent line, oh, there goes my dogs, will be equal to the slope of the secant line. Let me close the door here. Be quiet, Abby. Okay, so I just want you to make note of that what we found. That at x equals 5, the tangent line has the same slope as the secant line the dog's a psycho. And we'll say through 4, 6, and 6, -2. Okay, so when you're going through this, again, I want you to always think about what am I doing, why am I doing it, and that will help you remember how to use the mean value theorem. You could just follow these rules here and just randomly plug stuff in and have no understanding of what you're doing on every step, and you will never remember how to do this. It will just be a big pain. So I want you to think about it all the way through. Okay, that's it.